So this is a video on mixture problems with a little bit of notes first, and then we're going to do an actual example. So the concept of a mixture problem is that we're adding two things together to make a final solution, or two mixtures if you like. For example, we can add orange juice and ginger ale to make a fruit punch. What we're going to be doing is we're going to be borrowing properties and methods from chemistry to help us summarize the information, but then also to develop a linear equation to solve for our desired unknown. So the first property from chemistry that we're going to use is that if we have different amounts of different mixtures, when we add them together, we can just get the amount of our final mixture. So for example, if I have 5 liters of orange juice and 1 liter of ginger ale, I'm going to get 6 liters of my punch with those two together. The other property we're going to use is that the amount of a particular ingredient in each of our mixtures, if we add those amounts, they'll equal to the amount of the ingredient in the final mixture. So, for example, we can think that both orange juice and ginger ale have sugar in them, and if we calculate the amount of sugar in the orange juice and calculate the amount of sugar in ginger ale, then we can add those two amounts and get the total amount of sugar in our final fruit punch. But the question is, how do we get that total amount of sugar in each of our mixtures? So to calculate this amount of ingredient in a mixture, again we're borrowing from chemistry, and we're going to use our concentration or percentage. So for example, in the orange juice it would be a certain percentage of sugar. So as an example, I'm going to give you my particular orange juice is 12% sugar. So if I have 2.5 liters of orange juice, how many liters of sugar are actually in that 2.5 liters of orange juice? Well, it's a simple calculation. All we need to do is change our percentage to a decimal, multiply it by the volume of the liquid we have, which is the 2.5, do the little multiplication, and you can see that 0.12 times 2.5 is equal to 0.3 liters of sugar in the orange juice. Once we're able to do that, now we can use and summarize all our information. We're going to do this in a table template just to make it easier to see the information, to summarize it, and then also to see where the linear equations come from. So you can see here that we'll have mix 1 plus mix 2 is equal to the final mix. We'll figure out the amounts of each of those mixtures. We'll look at the percentage of an ingredient and then convert that percentage to decimal. And then we'll calculate the amount of our ingredient. And remember, the amount of the ingredient is just the amount of the mixture times the percentage of ingredient. If you want to see additional examples for this, you can refer to your textbook, page 44, example number 5. They do it with a slightly different method, but again, you can choose whether you like the textbook method or whether you like the table method. So let's try an example. So here's the template of my table with the mix 1, mix 2, the final mix, the amount of the mixture, the percent of what we have, and the amount of what we have. So you can see here our example is how many liters of a 20% glycol solution need to be mixed with 30 liters of a 50% solution to obtain a final 40% glycol solution. So our ingredient of interest is this glycol. See, we have 20% glycol, 50%, and then 40%. So that's why we have here for the percent ingredient glycol, and then the amount of the ingredient glycol again. So let's populate our table with the given information. So we have 20% glycol mix. That's what we're going to call our mixture 1. We want to add a 50% glycol mix to that. So that's our mixture 2. And we ultimately want to obtain a 40% final solution. So there's our concentration for our final solution. We're then going to take a look at the different amounts of our mixtures that we have. And we're given one value, 30 liters, and we know that that's 30 liters of the 50% solution. And we want to know how many of the 20% solution are needed. So this is the summary of all our information, and now we can start using our properties or methods from chemistry. So the first thing we can look at is the amounts of the mixture. So remember we said we could add the amount of mixture 1 plus the amount of mixture 2, and that's the amount of our final mixture. We can see now that we have a blank over in this last column. And remember that since it is the amount of the ingredient, which is the glycol, how do we calculate that again? Well, we need to take the amount of our mixture times the concentration, and then we'll get that amount of ingredient. But what we need is those percentages in decimal form. Now that I've switched them to decimal form by dividing through by 100, we can populate that last column. So x times 0.2 is x times 0.2. That's our amount of glycol in mixture 1. times 0.5, there's our amount of the glycol in mixture 2, and the amount of glycol in our final mixture is just the 30 plus x times 0.4. And where our equation is coming from that we can solve for x is from this very last column here. So here's where we get our equation, linear equation that we have to solve. And remember we said that the amount of glycol in mixture 1 plus the amount of glycol in mixture 2 has to equal the amount of glycol in our final mixture. We can do our algebra for this equation, and you can do that on scratch paper beside. And if you solve for x, you should get that we need 15 liters of the 20% glycol solution in order to get our final 40% glycol solution.